Prompt engineering has a ceiling. To break through it, you need to understand fine-tuning. Today I'm breaking down the technical process of training a custom GPT model. I'm going to show you how to use fine-tuning to shorten your prompts, lower your latency, and increase your model's accuracy. We're going to look at when to fine-tune your model, when not to, and I'm going to show you exactly how to do it inside of OpenAI. Let's get into it. So this is where you fine-tune GPT models. We are inside of the dashboard of OpenAI's website. You go all the way down to fine-tuning, and this is actually where you build your models. Fine-tuning your model is essentially giving your GPT model a bunch of examples of what good outputs look like for whatever your use case is. You give a minimum of 10 examples of what it can expect as an input and what it should output. And this helps to train the model to create responses that are specific to your task that it can replicate over and over. You're essentially teaching your model how you want it to speak, how you want it to output, or even giving it a unique personality. So let's think about a normal ChatGPT interface right here, where you go and you communicate with the chat. As you know, when you're communicating with this chat, it's back and forth communication. I send in a chat, I get a response back. I send in another chat, I get a response back. Fine-tuning is replicating this process, except you're deciding what the ChatGPT output looks like, so that when you go and use this trained model, you're going to go and get responses that look like the outputs that you created. That is essentially what the fine-tuning process is. I also want to add that the fine-tuned models that you do create, they're either used in the dashboard that is in here. More likely than not, you're going to be using it with the API, so inside of make.com, inside of N8N, anywhere where you're leveraging OpenAI outside of ChatGPT. That is the most likely use case. So when is fine-tuning a good idea? Number one, latency and token savings. Fine-tuning allows you to shorten your prompts. Instead of a 2,000 word instruction manual as your system prompt or your user prompt, you bake those instructions into the model's training. So every time that you're running the model via the API, you can have a much shorter prompt. That's going to save you a lot of tokens per run. And in the long run, if you're going to be using this model a lot, it's going to save you a good amount of money. If you have a style, format, or logic issue that you can't solve with instructions alone, then fine-tuning is probably a good idea. If you need the model to consistently output JSON or whatever other format, and the model consistently is messing up, then fine-tuning is probably a good idea. If you are looking for a very specific brand voice or tone, this is also a good idea, especially if you're going to be using the model a lot. When the model keeps consistently failing at specific nuanced tasks like coding or citation, despite very clear instructions, fine-tuning is probably a good idea. When is fine-tuning a model a bad idea? It's a bad idea to train a model if you want to teach it facts. If you're looking to give your model information, you're better off using RAG or MCP. It's also a bad idea if the use case involves rapidly changing information or pieces. If your data changes weekly, you don't want to keep having to retrain your model. Training is actually pretty expensive compared to a normal API call. Lastly, many people fine-tune because they can't get the prompt to work. In a small use case, usually a more improved and optimized prompt is probably going to be better and more effective. So the example that I'm going to build for you today is based on this automation right here that qualifies companies for my cold email campaigns. A company gets passed through to here. We have a company summary, and this GPT analyzes that company summary based on a bunch of criteria and outputs whether or not they are qualified or not qualified. That is the example I'm going to build. So instead of having to use this long prompt right here, I could go and input my fine-tuned GPT in here and have a much shorter system prompt or user prompt to yield better results depending on how much training I am giving to this fine-tuned GPT. So let's go over and build this GPT. The first thing that you're going to want to do is you're going to want to build a .json lines file. This is all of your training data, and then you want to upload it to storage here for GPT to have access to. You can do this in many different ways. There's a bunch of different applications that can do it. I built mine in Studio Code. This is a Microsoft app, but essentially you need a minimum of 10 messages. Each of those messages consists of a system prompt. You're telling it what to do based on the summary below. Determine whether the company is a good fit for a consulting firm that helps reduce solid waste and recycling costs. Only output one of the three: qualified, not qualified, or needs review. And then we give it a user prompt. So the user prompt is when you're actually expecting a result from ChatGPT. When you're actually typing into ChatGPT, into the typical user interface, the user prompt is what you're saying. The assistant prompt, which we'll see down here, is response we're expecting out of it. So the user prompt, we give a company summary asking whether or not they are qualified, and then we have an assistant, which is us replicating what a good response would look like. So the assistant, this is ChatGPT's response: qualified, not qualified, needs review, qualified, not qualified, needs review, qualified, qualified. This is what this JSON line file looks like. It's better to have more lines here. According to the documentation, 50 to 100 examples is where you want to be at. The minimum number is 10, so that's what I'm going to give you today, but the more examples you provide, the better the model will perform and yield the results that you're expecting of it. So I downloaded this file as a JSON line file. I then went ahead and I uploaded it into storage. Now we're going to go over to fine-tuning and we're going to build out this model. We go ahead and press create. So the method that we want to select is the supervised method. This is the method of giving it good responses. You also have the other types of fine-tuning methods where you're maybe giving it examples of bad responses, but we're going to stick with the supervised method. The model that we're going to choose, we're going to go with 4.0. The suffix is just what the model name will look like when it's finalized, and basically the name of the model. We'll say qualification, we'll keep it all in lowercase, qualification-model. The seed is the random ability of your model. You have to select an integer. We're just going to select 1. This is where you're actually uploading the file. Because we already uploaded it to the storage, we're just going to go ahead and select an existing one. We're actually going to go and type it in. So we're going to start with file dash, and I had copy and pasted the file ID. So that should be good to go. We're going to leave this at none. And we're going to leave these as B. So let's go ahead and create this file. And we have triggered the training of our new model. It is a little expensive, and I'll show you the final cost once we're done. The more lines of code that we have, the more expensive the training is going to be. So with 10 lines, it's going to be cheaper, but the model may not be as good as having more lines of code. Alright guys, so the fine-tuning took a little bit longer than I was expecting, and I'm actually recording a day after I recorded the first part. The fine-tuning was a success. We started at 4:30 p.m. and the fine-tuning ended at 5:52, so almost an hour and a half total. If we look right here, the fine-tuning didn't actually start until an hour after I initiated the fine-tuning. The reason is because it was queued up and the server was busy, probably fine-tuning other jobs. But once the fine-tuning started, it took about 22 minutes. And this is with the minimum number of epochs. I only had 10 examples. If you were to do 50, I'm sure it would be much longer than that 22 minutes. So if you want to go test out your model, you just go over here to Playground. And in this playground that pops up, you're going to have your model here, your trained model on the right. On the left side, it's going to be a default model. And essentially, you're able to add a system message and a user message in order to compare how the outputs differ between the base model and your newly trained model. This can help to showcase how well your model was trained and allows you to play around with the system messages in order to yield the output that you're actually looking for it. So this is extremely helpful if you want to see how your new model is performing versus the base model. So if we look at the number of tokens associated with this training, we have 9,630 total tokens. That is pretty expensive. Let's go ask the chat how expensive this actually is. How much did fine-tuning a GPT model, fine-tuning a 4.0 GPT model cost me with 10 epochs, yielding 9,630 tokens total? Okay, so it's actually going to generate a developer message here. I'm going to go in over here and ask how much that actually was. Costed me $0.25. I mean, that really wasn't that bad. It's not too expensive, but if you have 50 epochs, multiply that by 5, that's over $1 for training. So I guess it's pretty expensive compared to a normal API call. But just to give you an idea of how expensive that'll be. So now what we're going to do is we're actually going to utilize this model and put it inside of a make.com automation. I'll show you exactly how to do that. It's very, very simple. You just need to make sure that your API is correctly hooked up to make.com. You then either add a new OpenAI module or take your existing OpenAI module, and all you have to do is select the model here. You're going to want to refresh your model. It should be categorized with the model that you actually trained. So I did train a GPT 4.0 model, and as you can see I have 3 right here, and it looks like this is the correct one right here. So here's my model, and that's essentially how you connect it up to a make.com automation. Super simple. I can trim down this system or user prompt because now that the model is trained, it has prior information about what to do. If you found this technical breakdown helpful, hit the subscribe button. I'm dropping blueprints like this every week to help you scale. If you have a specific fine-tuning use case you're struggling with, drop a comment below and I'll jump in to help. Thanks for watching. See you next time.